Unit 6.1 Part 1, and we're going to look at exponents again, but we're also going to look at their graphs. Right, let's have a look. Because we're talking about exponents, we're actually talking about exponential functions in this part. So if I write a function, I write it like that, and it is b to the x. So the x is the variable. So remember it this way: if the x is the exponent, then it's an exponential graph. This base is a fixed number. It's a constant. Remember, constant is the word we use for a fixed number. But there are some restraints on it. It cannot be a 1. If it's a 1, it turns out not to be an exponential function. And it must be a positive value. So in order to be an exponential function, your base number, which will be a number, must be positive but not a 1. Okay, remember your rules of exponents. Remember I don't really have time to fit them all, or space and time to fit them all in here. So please go back to your rules of exponents. You have to get them really down crack so you know what's going on. I want to go and look here at graphing. Now, there's two situations, and that depends on this base number. If your base number is greater than 1, so in this case here, we're going to look if your base number is between 0 and 1, because remember it must be positive. So in this case, it will be a proper fraction because it's less than 1. But of course, it can be written in a decimal form. First, we're going to look at this one, if it's bigger than 1. And I'm going to do it on the hand of an example. So f of x equals 2 to the x. And remember that f of x is really your y. And I'm going to set up a table. Now, a table is not enough if you don't know the basic shape of this graph. So I'm only choosing 3 values for x, and they are values situated around 0. Right, so now you go and you say y equals 2 to the, for instance, negative 1. 2 to the negative 1 is a half. So this will be a half. Then for 0, y equals 2 to the 0. Anything to the 0 is 1. For 1, y equals 2 to the 1. Of course, you can also do these calculations on your calculator, but really we must learn to do some stuff in our heads. Right, I'm going to do the sketch here. And again, remember, you will not draw curly lines like I'm drawing here. You will use a ruler and measure properly. So this I would probably make every centimeter. And maybe I made this every 1.5 centimeters. as long as your scale on the y-axis stays the same all the way through and on the x-axis stays the same all the way through, the x and y-axis don't need the same scale. Right, if we start from 0, we go to -1, we have to go up to +1/2, which is there. If we start from 0 and we only go up, we get to 1. We start from 1, we go to 2. This will not be a straight line. It is not a straight line graph, right? It's a curve. So that's why I'm saying the points won't help you if you don't know the basic curve shape of an exponential function. We're going to look at some things. One is it is always increasing. Remember, increasing, you don't look where the arrows are. You look that if I move from left to right, am I going up or down? The domain, which x's can I use? I can use all x's. Any real number. You can work out 2 to the power of any real number. It will never give you an error. The range is not the same. The range is the y values, and this line here never crosses the x-axis. So y will always be greater than 0, but it could go up forever, up to infinity. Here's a new word. You have a horizontal asymptote. Horizontal asymptote. That is, what does this graph never cross? We said it never crosses the x-axis. So the horizontal asymptote is the x-axis. The equation of the x-axis is y equals 0. Right, let's just go back here. We have no x-intercept, because we've already said it never crosses it. It has a y-intercept at 1, at y equals 1. Right, we're going to compare the two, as I said. So in this case, let's use fx equals 1/2 to the x. Just also remember that 1/2 to the x is the same as 2 to the -1 to the x, so 2 to the -x. So if I do my little table, again, you're welcome to use your calculator, but you should actually be able to do this. Now, if x is -1, then you have 2 to the -1, so 2 to the +1. Anything to the 0, always 1. When x is 1, then you have y equals 2 to the -1, which is my 1/2. So the graph here's my -1, here's my +1, here's my 1 and my 2. Now -1 goes to 2, 0 goes to 1, 1 goes to 1/2. So there it goes. So this graph is always decreasing. If I go from left to right, I'm dropping. Most of the other things are still the same though. The domain, which x's can I use? still any real number. You can still find 2 to the negative anything. And the range, which y's do I get for answers? Still only bigger than 0 up to infinity. And it still has the same horizontal asymptote. So it still doesn't cross the x-axis, but its equation is y equals 0. Y-intercept still equals 1, still no x-intercept. Right, so remember the word asymptote is where the graph does not cross. And this one is horizontal because the x-axis is a horizontal line. So these are your basic ones. The basic info still stays the same. So the only difference, if your base number is bigger than 1, then your graph is always increasing. If your base number is between 0 and 1, your graph is always decreasing.